Okay, welcome everyone to the Poultry Health Research Network seminar series, and it is indeed my pleasure to introduce Dr. Stephanie Torrey, and this is going to be our last, I think it is actually our last seminar in our cycle for this year, and hopefully we're going to be picking things up again in 2018. Having said that, we're very pleased to have Dr. Stephanie Torrey giving a presentation. Dr. Torrey is a research scientist and associate graduate faculty at the University of Guelph in our next door department in animal biosciences, and she's worked for 2 decades in farm animal behavior and welfare. Dr. Torrey was born and raised in Massachusetts, USA, and she has a BSc in biology, or actually it says Bachelor BS in biology.
Yes.
From Worcester Polytechnic Institute, and an MS in animal science from Purdue University, followed by a PhD in animal science from the University of Guelph. This was followed by her experience as a research scientist with Agriculture and Agri-Food Canada for 9 years before she joined the University of Guelph. Dr. Torrey's research is focused on applied poultry behavior and welfare, specifically its meat birds like broiler chickens, breeders, and turkeys. Dr. Torrey's current research includes studies into feed restriction strategies for fast-growing broiler breeders, on-farm methods of euthanasia for chickens and turkeys, and behavioral predictors of health problems in turkeys, and the welfare of broiler chickens that have different rates of growth. Dr. Torrey has served as senior editor for the International Society of Applied Ethology, and she's participated in the development of the codes of practice for the care and handling of multiple species. And she served as a scientific expert. She's a research writer and peer review coordinator, and she has been involved in many activities, including more recently as the coordinator of the MSc by coursework program in animal behavior and welfare at the Animal Biosciences Department at this university. So it is indeed a great pleasure to have you, Stephanie, and thank you.
Thanks. Is the volume okay?
Yes.
Can you hear me? Okay. Thanks for the opportunity to come, Ravi, for the invitation and to talk to you about the research that we're doing on broiler welfare. So why this? Why now? For those of you that haven't been following a lot of the popular press, you'd probably have to really purposely not look at the popular press to miss all of the reports on broiler production, antibiotic-free, slow-growing broilers, pledges towards GAP, looking at what's going on in the suppliers, getting rid of antibiotics. Again, big chickens are bad. Alternatively, slow-growing is bad. Getting rid of those giant chickens, what's going on, hopping on to the GAP standards, and certainly all over, particularly in Europe, a lot of countries and or organizations making pledges to switch to slower growing broilers. So if you haven't been looking at the literature, yeah, maybe now's the time to look at what's been going on in terms of the press with regards to slow-growing broilers. And most importantly, the one that just came out actually just last week in WhatAgNet, science doesn't support slow-growing broiler movement. And I cringe when I see this. I'm a scientist, and I think, what science did you use to come up with this statement? So I dare say that we don't have the science to say right now, let's switch all over to slow-growing broilers, or let's not use them at all. And really, that's a huge gap. And so I think on both sides of it, the activists and the producer groups are both coming at it saying, we want slow growing, we hate slow growing, and I'm trying to look at it from the science standpoint and say, well, let's get the data so we can actually determine how the welfare of the birds is with slow growing. Now, I've mentioned slow growing broilers a number of times. All those popular press articles say slow growing, but what is a slow growing broiler? It really depends on who you're talking to. So in different countries, particularly in Europe, they have different labeling schemes for animal welfare assurance. So Label Rouge in France stipulates that a slow-growing broiler reaches market weight at 81 days. So 2.1 kilogram market weight would give it at about 26 grams per day. Alternatively, RSPCA in the UK doesn't have a specific age limit. However, they do stipulate that any broilers marketed under their label use their specific slow-growing breeds that they have tested within their studies. Out of Germany, the Tierschutz label, I apologize for my pronunciation of that, they stipulate a growth rate of less than 45 grams per day, so marketing about 47 days. In the Netherlands, Better Living, 56 days. Whereas GAP, the Global Animal Partnership, that's really come under the microscope in North America, they're right now stipulating under 50 grams per day, which would give a growth rate to 2.1 kilo of 42 days. So you can see that there's quite a wide range of what people are considering to be a slow-growing broiler. And when you consider that, say, a Ross 308 or a Cobb 500, really the standard broiler strains, are reaching that 2.1 kilo in 35 days, that a slow-growing broiler under these various schemes will be reaching that same market weight somewhere between 7 and 40 days later. So really a huge range in growth rates of these birds. So how is broiler welfare today? How are the birds doing? Before I can talk about broiler welfare, we need to have a definition of what welfare is. Most of you, I'm sure, have heard of what the 5 freedoms that came out of the Bramble Report in the early 1960s. And those included freedoms like freedoms from hunger and thirst, freedom from disease, from pain, from discomfort, but also the freedom to express normal behavior. And over the last 50 years, there's been a lot of different discussions on what welfare is, and ultimately it may be up to an individual's ethical viewpoint on how they personally define welfare, or how a consumer would define welfare based on their value system. However, one common ethical framework that has been used came out of David Fraser's lab from UBC, and this is often referred to as the 3 circles. So taking into account the biological functioning of the animal. So some believe that welfare is strictly to do with how the animal is performing, their health, their reproduction, their mortality and morbidity. Whereas still others believe that welfare is strictly to do with how the animal is feeling. Is it stressed? Can it experience pleasure? Is it hungry? Does it have any fear? Whereas still others define welfare strictly from a natural living standpoint. So are the animals able to live under natural conditions? Are they able to display natural behavior? So from my standpoint, I see the value in all 3 of these approaches, and really define that optimum welfare as hitting that middle spot where all 3 of these circles are taken into account. So if we look at the biological functioning of broiler chickens today, these 4 studies were 4 large epidemiological studies that were done over the last 10 years, looking at physical parameters, things like mortality, severe foot pad dermatitis, hawk burns, and lameness. And you can see these were all just your standard strains that are growing to market at about 35, 36 days. So mortality was ranging, you have about 3% mortality over the course of the growing period. Severe foot pad dermatitis ranging anywhere from 11 to 50% of the flock. Hawk burns from 1 to 8%. And severe lameness, so these are birds that are having difficulty or unable to walk, ranging anywhere from 15 to 25%. So over the last 20 years, the different breeding companies have included various welfare parameters within their selection schemes. However, there still is room for vast improvement in terms of biological functioning of these animals. This chart is from a study by Alain and colleagues out of INRA, and what they did was an epidemiological study looking at 55 broiler flocks that were processed at 8 different plants in France. And what they found was that ultimately the majority of these plants were using one of 2 strains. They didn't identify them, but we can identify them just based, not identify them as their name, but the faster growing one growing at 46 grams per day, which you'll note is still considered a slow growing strain in some of the different assurance schemes, and then a slower growing strain growing at 35 grams per day. And at the slaughter plant, they assessed the foot pad lesions of these birds, hock burns, and breast blisters. And what they found was that the faster growing birds, so the ones in blue, 75% of them had deep foot pad lesions. And these are probably associated with a degree of pain in these animals, whereas the birds that had slower growing strains, certainly they weren't perfect. They still had an increased level of hock burns and increased prevalence of breast blisters. And what the authors hypothesized was that the faster growing strain had increased leg weakness, was spending more time, decreased activity, more time in contact with the litter, which was leading to that increase in the foot pad lesions. But conversely, they hypothesized that the other strain had worse skin quality. And they said that skin strength is genetically controlled, and perhaps they have thinner skin, which was leading towards the differences in hock burns and breast blisters. So not necessarily a straightforward relationship with growth rate, that there's different factors that are within perhaps the different genotypes that could be used to improve welfare.
Excuse me.
Sure.
What was the age of these 2 groups?
They differed by 6 days. So the fast strain was marketed at 1.8 kilos in 40 days, and the slow was 1.6 kilos in 46 days. So they're a 6-day difference and 200-gram difference. To the non-welfare scientists in the crowd, it may seem quite difficult to measure feelings in non-human animals, but there are scientific ways in which we can ask animals how they're feeling, both on the negative and the positive scale. And this study was done out of the group from Bristol that developed the Bristol walking scale, the Bristol gait score, that some of you may be familiar with. And in this study, they took a bunch of broilers and they sent them down a walkway. And from there, they assessed their gait. So they picked birds that had completely normal gait and those that had moderate, not severe, but a 3 on their gait score. And then from there, they gave a proportion of the birds carprofen, so anti-inflammatory. Some were just handled and others were injected with saline. And when they did this to the sound birds, those that had completely fine gait, they found that all the birds went down the walkway in about 30 seconds. However, when they looked at the birds that were lame, that had a score of 3 previously, they found that when the birds were given carprofen, they walked significantly, a greater proportion of the birds completed the course and at a faster rate. This is really showing that the speed and the walking ability of these birds, due to the lameness, is probably due to pain and inflammation as it was relieved by the carprofen. Stress and fear can also be systematically measured. In this study, a French group out of INRA compared the reactions of 3 Hubbard strains, a slow-growing strain here in the blue, a fast strain in the greenish yellow, and the heavy in the gray. And what they did was they looked at the bird's reaction to standard commercial practices, in this case shackling. So in the control group, they put the birds on a shackle for 10 seconds prior to stunning. So they were handled gently, put up on the shackle, stunned after 10 seconds. In the shackle group, they were put up on the shackle and then remained there for 2 minutes prior to stunning. And in the shackle in heat, they tried to simulate some fairly dreadful larynge conditions, and the birds were kept at 35 degrees C for 3.5 hours prior to then being put up on the shackle for 2 minutes and stunned. And they quantified the percentage of birds that were vocalizing intensely while on that shackle and the amount of wing flapping that was occurring. And what they found was that it was the slow-growing strain in blue that was having quite a significantly larger reaction to the shackle, even with the 10-second shackle time in the control. So a short period of perhaps intense unpleasantness, and these birds are vocalizing 40% of them quite intensely, and 7 seconds out of the 10 seconds they were spent violently wing flapping. So it's not always straightforward that we're going to see the slow-growing strains reacting positively and the fast-growing strains reacting negatively. So they surmised that it was the slow-growing birds that were exhibiting more fear, even in response to the short-term stress. Alternatively, the faster and the heavy strains were showing some learned helplessness in this condition. So it's important that we are taking into account we're looking at a number of different ways to look at welfare, because some of the strains may be more suitable for certain environments or certain procedures than other strains. And the final sphere, according to the 3 circles, includes natural living. And this may be a bit more difficult to evaluate under commercial conditions where things are quite different than what is truly natural for, say, a red jungle fowl, for better or for worse. But it is quite important for some that they see a chicken acting like a chicken. And so this team out of the Netherlands looked at the time budgets of 2 lines of Hubbard birds. So they had the fast line is in the open circles and the slow line in the closed squares. And what they found was even right from the 2nd week of life, the fast line was spending less time perching and more time sitting on the floor than the slow line, and this carried through their entire life. And so whether or not you feel that the behavior in and of itself speaks about the welfare of these birds, a high proportion of birds sitting on the floor means that they're coming in contact with litter, increasing the chance of breast buttons, hawk burns, foot pad dermatitis versus those birds that are up on the perch. Now, I'm going to shift gears just for one quick second, is that we're talking about slow-growing broilers. But I think one thing that's often missing as part of this issue is broiler breeder welfare. And as you know, broiler breeders are the parent stock of the broiler chickens, and they have the same potential for fast growth as the broiler chickens. However, because they're in production for a year, they need to be feed restricted so that they don't end up with some major welfare issues, including obesity, metabolic problems that lead to ascites and heart attacks and inability to walk. So these birds are severely feed restricted so that they can maintain this growth curve, which, as you can see, vastly differs from that of their broiler offspring, even though they have the exact same genetic potential. So these birds are feed restricted to about 40% of what they would necessarily choose to consume at the same age and time. And my team has looked at a number of nutritional and management strategies to reduce the hunger of these birds. And they work to a point. But to quote one of my son's favorite singers, Taylor Swift, that Band-Aids don't fix bullet holes, that there's only so much we can do to improve the welfare of these broiler breeders when we're using these strains that are genetically selected for this fast growth. So ultimately it does require slowing down the broilers so that we can see the improvement in the parent stock, regardless of what happens with the welfare of the broilers. So that aside, it brings me back really finally to our study. And our study is to really look at and ultimately improve the health and welfare of broiler chickens. And we had three main objectives for our study. The first, to determine the best behavioral and physiological indicators of welfare and health within our research setting. From after we have decided that, we are benchmarking data on the welfare of slow-growing strains using really taking a comprehensive approach and looking at behavior, physiology, health, production, and carcass and meat quality. And then finally, to determine nutrient utilization and benchmark indices of gut health and function. If all goes as planned and things are progressing well, ultimately we hope to take a few of these strains out into commercial systems and see how they do in a larger scale, but then also use our data to create a database from which a life cycle assessment can be done so that we can actually look at the full implications in terms of sustainability of these strains. I just want to take a minute to point out the personnel for this. This is quite a huge study, and we have a really great team that is working on this. So here we have Midian Nascimento dos Santos, here, a Brazilian native, completed her MSc at Mississippi State, and she's also an Arrowhead Food Institute research scholar. So she's doing her PhD on this study. We have Daniel Rothschild here, also back there. He's homegrown, having done his bachelor's here in animal biology, and worked in our poultry behavior and welfare group for a bit before returning back to school. Zhenzhen Liu up here did her undergrad at China Agricultural College with a 2-year stint at Waterloo. So she's working on her master's here. And then finally, Mohsen Mohammadi Gaysar is a postdoctoral fellow, native of Iran, who came through South Korea for his PhD. And he's a nutritionist, and he's working on all the diet formulation and the nutrient utilization work on this study. So for our study, we're using 3 commercial kind of standard strains that are just regularly used in industry. They come to market 36 days to reach that 2.1 kilo. And we're feeding these birds on both a standard high-octane diet and also a slower growing diet that has reduced levels of protein. And Mohsen is formulating these diets at our Arkell feed mill to meet the needs of the strains. In addition, we're using 17 slower strains. And these strains have very varying levels of growth rate. So they're going to reach that 2.1 kilo in anywhere from 40 to 120 days. The average is about 48 days, so quite a bit to reach in about that 7-week time period. And each strain will be represented in 4 pens and each of 3 replicates over time.
Excuse me.
Yes?
For the slow-growing birds, did you use the fast diet or?
No, we're using a slow diet. Yeah. We know that breeder flock incubation and hatching protocols, early feeding of the broiler chicks has an impact on the life of these birds. So we wanted to control this as best as possible. So all of the hatching eggs are being transported to Arkell. We're hatching them out at the research station from breeder flocks of really at their peak weeks of lay. All of the birds are vaccinated against bronchitis. They're getting some pneumococcs, vaccinated against Merrick's. And we're feeding them all antibiotic-free, all vegetarian diets because we wanted to mimic the requirements for birds on the Global Animal Partnership assurance scheme for their steps. The study is being done at Arkell. All the birds are in an environmentally controlled room with 28 identical pens, and the birds are housed at 29 kilograms per meter squared, which is a bit more generous than standard production, but is equivalent to what the higher welfare assurance schemes require. Within these environments, we have automatic scales here. We have a platform for the birds to go up onto or go underneath. Of course, round feeders, nipple drinkers, a peckstone mineral pecking block, and we also have some hanging ropes that aren't seen here. We're growing the birds to a target weight of 2.1 kilos, transporting them in a modular system to slaughter, which is about 90 minutes away from Guelph. And they're stunned with CO2 prior to exsanguination, and the carcasses are air chilled. So for our later parameters. And we'll be processing each replicate at 3 ages so that we can see really a range of final weights per strain. And each replicate will always be processed, have some birds processed at 35 days, and all of our standard strain birds will be processed at 35 days. And then the second processing will be between 42 and 56 days, and this is dependent on the birds that we have in that particular replicate, because we'll have birds of differing growth rates, so we're having them blocked together so that we can target their 2.1 kilogram within that middle processing age. And then our final processing age, we're really going to be pushing the envelope a bit and carrying the birds out to 56 to 120 days, again, depending on the strains that we have within each of those flocks. To look at the biological functioning of these birds, we'll be measuring things in terms of their production, their body weight, their feed intake, their feed conversion, but also looking at things like litter quality, which we know impacts the development of footpad dermatitis and hawk burns. Measuring ammonia within the environment to see if it differs among the replicates. Each of the strains will be in 3 replicates because we know that season plays a big role on, of course, in the amount of humidity in the environment and then the ammonia rates, and this may impact other physical or behavioral parameters. And we're also using our infrared camera to help us assess heat production and feathering. While our birds will not have the opportunity to go outside, we know that some of these birds have been really selected for being able to go out onto range. So we want to take into account whether some of these birds have this early feathering that will help them with their heat production, but also maybe protection in terms of our environment. You can see here that we have this platform, which is great, but broilers aren't the most graceful at descending the platform if they choose not to use that ramp. And so early feathering would also help to protect them if a pen mate decides to jump directly on their backs. We're assessing additional health parameters such as leg strength using a water bath test, and assessing the prevalence of footpad lesions, prevalence and severity of footpad lesions and hawk burns at slaughter. We're collecting blood samples to look at heterophil to lymphocyte ratio, and then to assess the antibody titers for Newcastle infectious bronchitis and infectious bursal disease. I mentioned that these birds are being fed antibiotic-free, and so we want to see if they vary in terms of their disease resistance within the same environment and management. Additional health parameters that we'll be looking at include things like long bone deformities, crooked toes, femoral head necroses, and tibial dyschondroplasia. And these will be measured either through the use of our digital X-ray machine or dissections of the carcasses. To look at affective state, how the animal is feeling, we'll be looking at gait score using standardized 3-point gait score. We're also using other standardized tests like the human approach test or a shackle test, which will allow us to quantify the bird's reaction to standard husbandry procedures that would necessarily happen under commercial production. And then behavior, we're looking at it both from the negative and the positive affect. So we want to see if the strains differ in perhaps the extended play behavior that occurs. Extended play would generally mean that the animal's needs are being met so that they can participate in some activities that perhaps are providing them pleasure and aren't necessarily behavioral needs within these environments. Conversely, we also saw in our pilot studies a lot of this extended leg posture. And we're not sure if this is a more comfortable posture for these heavier birds, if it's related to some heat dissipation, or if they would actually be uncomfortable if they actually had their full weight under the lying sternally. And we'll be looking more closely at the behavior to determine the bird's overall time budget so we can see how they're spending their time. Are they more or less active as the time goes on? So we have cameras above the pens, so we'll be able to watch them at different times of day and look at their resource use. How often are they going up on those platforms? Is that changing as they get older because they're not wanting to climb that ramp? Also perching on the water lines. We don't have specialized perches, but these birds, we don't have a wire over the water line either. So the birds can and do perch right on that water line, in addition to perching on their peck stone as well. We also have data loggers, so basically little Fitbits for our chickens that can help us use that automated technology to see the differences in activity levels within these strains and to see if that relates to any of the other indices of welfare within these strains. In terms of production, so not welfare parameters, but these are still quite important parameters for the poultry industry. We'll be getting the whole carcasses back and bringing them to our federally inspected meat lab. That allows us to look at yield and breast yield, and from the plant we can get the percentage of downgrades and condemnations. Working with our colleagues in the meat lab, we're looking at pH, white striping, woody breast, drip loss, and shear force. And we may at a later date add in some sensory characteristics and do some taste panels if time and money allow us to. So ultimately, will slower growth improve broiler welfare? Ultimately, we hope that our data will provide a comprehensive look at the spectrum in terms of growth rates of the strains that are out there, and see if there is a direct relationship with grams per day growth rate and welfare, or if there's a number of other genetic factors that are in play there. I don't necessarily anticipate that we're going to see this linear line in terms of welfare and growth rates, but time will tell over the next couple years. One of our esteemed colleagues, Dick Julian, said with regards to metabolic diseases that rapid growth alone may not be the mechanism that results in defects. So of course our birds are being reared at our kennel. Some would say that they are practically pets within these environments. They have enriched environments and good management, and we know what happens at the hatchery and transportation. So we're controlling for all of these different factors, but of course we're still on the higher end in terms of the management. So we're hoping to elucidate some of the factors that contribute to the welfare of broilers, but it may not strictly be the growth rates that come out as the causal factors. Moving forward, this project is funded in part through the CFREF, the Food from Thought grant. So we're trying to take the bigger picture and look at these strains, not just in terms of the animal welfare and the social sustainability of them, but also looking at production and ultimately environmental sustainability. And so, with a lot of hard work and probably some luck, we hope that we can identify some strains that fit into that sweet spot. Maybe that's a really idealistic thinking, but I think with our assessment of 20 strains, hopefully we can find something that meets everyone's needs going forward. So we have funding for this project from Global Animal Partnership, CFREF, the Food from Thought grant, and support from OMAFRA. I think there's a bit of time for some questions, and I'd be happy to talk to you, or you can catch a couple of my grad students here. So.
Thank you very much, Stephanie. Any questions?
I've got a question about the shackle test, because it looks like something we can potentially do to mice. And in mice, you'd hang them up by their tail from a cliff. And if they did nothing, you'd call that learned helplessness. And that's been validated by the increased metabolic stress being diminished with antidepressants. And so I wondered, with your broilers, how would you interpret what they do? If they flap wildly, is that bad? Or if they hang passively, is that bad? Or is everything bad?
Yeah, I don't know. We will be doing that, and also kind of the human approach test. So I'm not sure if learned helplessness has been validated for broilers, and maybe that's something that we can do as part of this, and then go forward and look at the results of that test. So my only thought in terms of kind of production on that, the study that showed that the slower birds had more violent wing flapping, is of course that risks breaking the wings, but certainly you don't want the learned helplessness, the birds that are just giving up and I'm just gonna hang here because I can't do anything else. So
Dr. Harwood? Can I ask you about the same test there? Were they doing in a processing plant, the shackle test?
they were, because they were stunning
Okay, so
within
I'm
that time
coming
period.
with my thoughts. I don't know if you consider it. When I see that, I was surprised to see that the lighter birds were flapping more or whatever. I don't know if you've seen it, but in the processing plant, I can imagine if they're larger birds and they're touching each other, they just calm down. And if they are separated, they will flip their wings much more. And I don't know if you've seen it in the studies also, the breastplates, if they go, they just calm them down.
Yep.
So I don't know, if they considered something like that?
I would have to go back into that study to see if they kept spaces on the shackle line between the birds. I would assume so, because they were looking at individually the vocalizations and the wing flapping, so I can't imagine that they had them one right after another like would be standard practice.
No, because if you use the same shackle line,
Yes.
the spaces, if
Yes.
you use each shackle, it can be 10 inch.
Yep.
shackle.
Absolutely.
If they use the same one and there's more space, even larger bird will flip. That's my experience.
Yeah.
they flip more.
Yep. Now, for our purposes, because the plant that we're using is CO2 stun, they don't have that shackle line anymore, so we are just doing it experimentally on our birds with just an individual shackle.
Do you use
So.
a regular CO2 stun for this?
I need to check, because they were just switching over to CO2 this fall, on what the specifications are for that.
Because the gradual will be much better.
Mhm.
for you.
Yeah.
Hopefully.
Thank you very much. You would probably need more results to come up with a recommendation to this. industry probably. But my question is a general question. Do you think that slow growing is economic?
I don't know, because I think we need more data on nutrient utilization and what goes in and what comes out of the birds. A lot of the studies, the science that would go into, say, these popular press articles is assuming that they're eating the same density of diet, perhaps the same expenses, the same feed conversion, although slower feed conversion for these slow-growing strains. But also they're assuming that the same level of mortality and perhaps downgrades and condemnations. So I think absolutely for the slowest strains, I think it's going to cost a lot more. But perhaps those ones that are growing a week or two slower, perhaps they can be done quite economically using a lower protein diet and minimizing the amount of mortality that's going in there.
Because for the fast growing meat, it's already proved that when you try to slow the growth of these birds, it will have a great effect on the health and quality of the blood pressure. Because it reduces the leg problems, it reduces the sinus and some of the problems, some metabolic problems. So I was wondering if raising the broilers, for example, for 80 days into 20 days, because they will be in exposure to the problems that they have to be facing during the production.
Yeah.
During 40 days, yeah, a lot of, but during 120, it will be much more.
Yeah, well, the caveat will never take those standard strains out to 120 days because they'd all be dead. But even we're going to, the majority of those slow growing, the fast strains will be at 35 days. We'll be feeding them on fast and slow diets. So it would be the ones on the slower diet that would be able to go later, whether or not the 120 days is taking into account some of the strains that have much slower growth rates.
Thank you for the talk. I may have missed it. Are you taking litter samples for moisture and ammonia in these pens?
We're taking litter samples for moisture. The ammonia is more the air, and I think it's right above the, Midian would have to, it's right above the litter in terms of the ammonia.
And my question just stems from my experience in the field, being in farms with slower growing broilers. They end up being a little bit more dusty. And so I'm just curious if you think that might have an impact on disease spread or risks of disease spread when the environment's so much dustier and drier.
Yeah, and it may, and that's why we're going to look at the immune parameters. Within each replicate, we will have 7 strains. So it's not a perfect system, but to get through 20 strains in the amount of time that we have and to get enough replicates, that's the downfall of that.
Why are you passing them so nicely? I mean, I really like that you are, but what if there's gene or environment interactions, then you
Yeah, so the picture that you saw there was our pilot, where they were half the density. So I'm not sure if you would, at the end of production, say that they are glorified pets. I think our last trial, we had quite a bit of had dermatitis, and the litter was quite wet, which from a welfare standpoint is not good, but I know that some industry were like, oh, we're glad that you have real crappy litter because it's real. So certainly the 29 kilograms per meter squared, we wouldn't use it for just experimental basis because it's, what we would just walk in and say, oh, they're too tight, but it still is what's being used in commercial industry. Yeah.
We've had a lot of lively discussions, and probably we can call it a day and adjourn the seminar today. Once again, thank you very much for giving the talk, a wonderful and very mentally stimulating talk. So thank you, and